Hello everyone. Last few classes we have discussed about closed loop system to control the current, torque, speed of electrical machines. But those closed loop system are not sufficient or not enough to obtain better speed regulation. So for better speed regulation, some other closed loop system is to be considered. Today we will discuss phase lock loop control system that is generally used to obtain better speed regulation. So let's see those things. Due to error in sensing and control circuits, the closed loop scheme discussed earlier can at best achieve a speed regulation of 0.2% only. But the phase log loop control can achieve a speed regulation as low as 0.002%. So it is better. That's why in sophisticated devices like conveyors, paper and textile mills, as well as computer peripherals, this scheme is used. Let's discuss about these things. Phase log loop control. Here it is a phase detector. It will detect the phase difference between two input train of pulses. So here it is the reference one or the desired one, and this is the train of pulses coming from the output side. Now after comparing this phase detector, will generate a pulse width modulated voltage control signal. Now this pulse width modulated voltage control signal magnitude will increase if phase difference between this one is more, or will decrease accordingly. The magnitude of this voltage control signal may be positive or negative based on this signal is lagging this signal or leading. Now after obtaining this pulse width modulated voltage control signal, it is fed to a loop filter to obtain a DC output voltage, and that is generally control voltage for this converter. Here it is nothing but a voltage controlled oscillator. Upon getting this DC input signal, it will generate a frequency of output signal. Now this output signal again becomes the input of this phase detector, and this voltage controlled oscillator will generate this frequency in such a way to reduce the phase difference between these two signals. That means this voltage control oscillator operates in such a way to reduce the phase difference between these two signals upon getting this control signal. The same thing is written here. You can go through this one, and this process continue till f is equal to f star. At that time the system is said as the loop is logged. That's why the naming is phase log loop control system. Now let's see its application in electrical drive system. So in electrical drive system we have converter, motor. So to control the speed of the motor, we have to control the switching pulses of this converter. Now to control the switching pulses of this converter, obviously we have to control the pulse width modulated input or the on period of the switches. Now how this signal we will get? Here the voltage control oscillator is replaced by this converter, motor and speed encoder. The function remains same. This converter, motor and speed encoder will operate in such a way to reduce the phase difference between these two signals. So this is f star is nothing but reference signal, and this is the sensed signal, or you can say the output of this speed encoder. Continuously it is being sensed and fed to this phase detector, and pulse width modulated control output we will get. After filtering this one, this becomes the control voltage for the pulse width modulated inverter or converter. Now this control signal pulse width will change as per the phase difference between these two signals. So the on period of the switches are being controlled. At the same time, speed of the motor is controlled. Now this loop will be logged when speed of the motor, or you can say this train of pulses, becomes equal to the reference signal. Then the system becomes logged and the motor will rotate at desired speed or the speed according to this f star. Now from this closed loop it is clear that If we are able to control this Fs star, then we can control the speed of the motor as well as the speed of the load. Now the advantage of this one is that excellent speed regulation, already discussed that it is better 0.002% approx you will get. And disadvantage of this system is that transient response is slow and it has a low speed limit below which it becomes unstable. So range of operation is very small. So accordingly we have to select the application of this phase log loop control system. Let's proceed. Here it is a closed loop position control. So in this case what happens, position of the rotor or position of the shaft is sensed with the help of this position sensor. It is nothing but generally Hall effect sensors are used to sense the position. So this is the position of that shaft. This is the reference position we want. Just like earlier closed loop system, here also there will be comparison between these two sensed and the reference value, and the error will be generated, and that error is fed to this position controller, and this position controller will generate a reference signal for this speed limiter. Now it is nothing but just beyond this range of speed it will saturate. Here also in the negative direction it will saturate. So when it saturates, then it will generate a reference signal for this closed loop speed control. It is nothing but an inner current control loop, already discussed in earlier classes. Here what will happen, this speed limiter will generate a reference current that will be the maximum allowable current flowing through this converter and motor. Accordingly the speed of the motor will be controlled to control the speed of the load. Now this application it is used to feed drive in machine tools and screw down mechanism in rolling mills. So whatever I have discussed that is written here, you can go through this one. Okay, so today we have gone through in brief about phase log loop system, and we have seen that how this PLL system can control the phase difference between the two input signals and ultimately control the speed of the motor. But in this case we have seen that phase log loop system is better than earlier torque, speed and current control systems, because the speed regulation is smooth and better. Then we have seen position control system and seen that position control system, by controlling the position of the shaft of the rotor using Hall effect sensor, we can control the speed. So in brief we have gone through in this module control theory. In detail you will see these things in control system. So our purpose is to understand the behavior of the system, or to understand the closed loop system, how it will work to control the speed of the motor. From next classes I will start DC motor drives. There we will see in detail about control of DC machines. Thank you.